First of all, what went through my mind is how stupid am I to actually
Welcome to our channel. Today we're diving into the fascinating world where art meets mathematics. Get ready to explore 10 remarkable works of art that showcase intellectual and mathematical depth. So, buckle up, space cadets, as we blast off on a journey to explore the universe of mathematical art where creativity knows no bounds. What exactly is mathematical art? Is it some secret society of artists who moonlight as mathematicians? Not quite. It's a genre where artists incorporate mathematical concepts into their work. Mathematics is the language of the universe, and art is how we express that language. From simple circles to complex fractals, math provides the building blocks for patterns and structures. Ancient Greek architects used the golden ratio for harmonious proportions. Math continues to inspire artists today, blending art and science. Algorithms and data create stunning visuals that blur the lines between art and science. We often think of the logical and the creative as separate domains, but mathematical art reminds us that the universe doesn't recognize these boundaries. Whether it's Islamic art or M.C. Escher, see the world through a new lens. Let's start our journey with a concept that has captivated mathematicians and artists for centuries: the golden ratio, often represented by the Greek letter phi. This special number, approximately 1.618, pops up everywhere in nature, from the spiral patterns of seashells to the arrangement of seeds in a sunflower. But what makes it so special? It creates proportions that are naturally pleasing to the eye, a kind of universal harmony that resonates deep within us. Renaissance artists were particularly obsessed with the golden ratio, believing it held the key to unlocking divine beauty and balance in their art. Take Leonardo da Vinci's Mona Lisa, for example. Her enigmatic smile, her perfectly balanced features, it's believed that Da Vinci used the golden ratio to achieve those mesmerizing proportions. From Michelangelo's David to Botticelli's Birth of Venus, the golden ratio can be found lurking in the masterpieces of the Renaissance. It's a testament to the power of observation and the enduring human desire to understand the universe and our place within it. Buckle up, folks, because we're about to enter the mind-bending world of M.C. Escher, a Dutch graphic artist who used mathematics not to find harmony, but to challenge our very perception of reality. Escher's works are like visual paradoxes, playing with perspective, geometry, and space in ways that leave you scratching your head and marveling at his ingenuity. Take his famous lithograph Relativity, for instance. It depicts a world where staircases ascend from multiple perspectives, defying gravity and logic as we know it. It's a visual representation of non-Euclidean geometry, a branch of mathematics that explores spaces beyond our everyday three-dimensional experience. Escher's works are proof that mathematics isn't just about cold, hard numbers, it's a playground for the imagination. His impossible constructions, tessellations, and mind-bending landscapes invite us to question what we think we know about the world. They're a reminder that the universe is full of mysteries, and sometimes the most profound truths are hidden in plain sight. Get ready to have your mind blown wide open by the mesmerizing world of fractals. These infinitely complex patterns are created by repeating a simple process over and over, and they're found everywhere in nature, from the branching of trees to the intricate patterns of snowflakes. One of the pioneers of fractal geometry was Benoit Mandelbrot, a Polish-born mathematician who used computers to visualize these intricate structures. His most famous creation, the Mandelbrot set, is a visual representation of a mathematical equation that produces an infinite variety of shapes and patterns. Zoom in on any part of the Mandelbrot set, and you'll find an entirely new world of complexity, mirroring the patterns of the whole. Fractal art isn't just visually stunning, it has revolutionized our understanding of nature. It's used in fields like computer graphics, weather forecasting, and even medicine, showing us that the universe is far more complex and interconnected than we ever imagined. Leonardo da Vinci wasn't just a master painter, he was a true Renaissance man, excelling in science, engineering, and anatomy. His curiosity led him to explore the human body, culminating in the iconic Vitruvian Man. This drawing of a man in a circle and square explores human proportions. Da Vinci saw the human body as a microcosm of the universe, illustrating mathematical principles. Based on Vitruvius's writings, the ideal body is perfectly proportioned. Da Vinci incorporated his own observations, using the golden ratio for balance. The Vitruvian Man shows art and science as inseparable, two sides of the same coin in knowledge pursuit. Prepare to be transported to a world of intricate beauty and mesmerizing patterns as we explore the mathematical marvels of Islamic art. In Islamic tradition, the depiction of living beings is often limited, leading artists to focus their creativity on abstract forms and geometric patterns. Islamic artists developed an incredibly sophisticated system of geometry, using compasses and rulers to create intricate designs that seem to stretch on forever. These patterns, known as giri, are based on a set of basic geometric shapes such as stars, polygons, and circles that are repeated and interlocked to create complex and mesmerizing designs. From the tile work of the Alhambra to the mosaics of the Blue Mosque, Islamic art is a testament to the power of geometry to create beauty and inspire awe. These geometric patterns weren't just aesthetically pleasing, they were seen as a reflection of the divine order of the universe. Get ready to meet the Fibonacci sequence, a series of numbers that holds the key to understanding everything from the arrangement of petals in a flower to the spiral patterns of galaxies. This sequence, which starts with 0 and 1, follows a simple rule: each subsequent number is the sum of the two before it. What's amazing is how often this sequence pops up in the natural world. The number of petals on a flower, the spirals of a pine cone, the branching of a tree, they all follow the Fibonacci sequence, a testament to the underlying mathematical principles that govern growth and form in nature. Artists have long been fascinated by the Fibonacci sequence, incorporating it into their work to create harmonious compositions and evoke the beauty of the natural world. From the spiral arrangement of figures in Leonardo da Vinci's Last Supper to the dynamic compositions of modern sculptures, the Fibonacci sequence continues to inspire artists to this day. Hold on to your hats because we're about to enter the world of Bathsheba Grossman, a contemporary sculptor who takes mathematical art to a whole new dimension, literally. Grossman uses three-dimensional printing technology to create sculptures that are as mind-bending as they are beautiful. Imagine holding a complex mathematical equation in the palm of your hand, feeling its curves and contours, and marveling at its intricate geometry. She transforms abstract mathematical concepts like algebraic surfaces and topological shapes into tangible objects that you can hold, rotate, and explore from every angle. Her sculptures blur the lines between art, science, and technology, challenging our assumptions about what sculpture can be and how we experience it. Fasten your seatbelts because we're about to enter the digital realm of algorithmic art, where computers become creative collaborators. This innovative form of art uses algorithms or sets of rules to generate complex and often unpredictable visual patterns. One of the pioneers of algorithmic art is Manfred Mohr, a German artist who began using computers to create art in the 1960s. Mohr's work is characterized by its geometric precision and its exploration of complex mathematical concepts. Algorithmic art challenges our notions of authorship and creativity, taking us to the heart of what it means to be human in an increasingly digital age. We're revisiting the mind-bending world of M.C. Escher, but this time we're focusing on a concept that permeates his entire body of work: symmetry. Escher was obsessed with the idea of repeating patterns, using them to create illusions of depth, movement, and impossible spaces. Think of his famous lithograph Day and Night, where flocks of birds morph into each other, creating a seamless transition between light and darkness. Or Reptiles, where flat lizards seem to come to life, crawling off the page and back again in a continuous loop. Escher's use of symmetry wasn't just about creating visually appealing patterns, it was about exploring the fundamental principles of order and balance in the universe. Get ready to explore the world of Piet Mondrian, a Dutch painter who used mathematics to create a new language of abstract art. Mondrian believed that art should be stripped down to its purest essence, free from any representational elements. His paintings are characterized by their bold geometric forms, primary colors, and use of horizontal and vertical lines. He believed that these simple elements could express the universal harmony that lay beneath the surface of the visible world. Mondrian's work is a testament to the power of reduction, revealing the underlying order and beauty of the universe. Thanks for joining us on this intellectual journey through the world of mathematical art. We've traveled from the golden ratio to the Fibonacci sequence, from Escher's mind-bending illusions to the digital landscapes of algorithmic art. Remember, the next time you encounter a complex equation or a mind-boggling piece of art, don't shy away. Embrace the mystery, explore the unknown, and never stop asking questions. Don't forget to like, subscribe, and hit the bell icon for more fascinating content. Until next time, keep exploring the cosmos, both within and beyond.